Hello everyone. Today's topic is linear programming. Before we start with the topic, let's try to understand the literal meaning of linear programming. Linear stands for a linear mathematical relation, means of degree 1, and programming means it refers to a method of determining a particular program or a plan of action. Now let's discuss the importance of studying linear programming. This particular topic of mathematics is a very important and integral part of applied mathematics. This topic is very much applicable for the industrialist, for various organizations, manufacturing units, and so on. Let's start with a small story. Once upon a time, there was a person named Alex. Alex thought of starting with a new business. He found that he has 50,000 bucks in his bank account, and he also had a very small godown. He kept on thinking that what kind of business he should start. Then finally he decided that he will start with import and export of tables and chairs. He did a lot of survey in the market and he found that the best cost for a table, the cost price which he will get from a wholesaler or a manufacturing unit is rupees 2500. So the best price for the table he'll get is rupees 2500, and for each chair he has to pay rupees 500. Then he did a lot of survey in the market and found that if he sells his product at a very competent price, he will gain rupees 250 per table and rupees 75 per chair. He also discovered that in his godown he cannot keep more than 60 pieces. Now the problem is how many tables and chairs he should buy so that he has maximum profit. And we know the limitations which he has. He has only rupees 50,000 to invest and he doesn't want to take any kind of loan. And the space available allows him to store only 60 pieces. He cannot buy more than 60 pieces. Alex thought, if he goes for all the tables, if he buy all the tables with the money which he has, that is 50,000 bucks, the cost of each table is 2500, means with 50,000 bucks he can purchase 20 tables. And the profit for each table is rupees 250, and for 20 table it will be rupees 5000. And in case instead of tables he goes for chairs, the cost of each chair is rupees 500. He can buy 100 chairs, but again the problem is storage. He can't store more than 60 pieces. So in case if he goes for all the chairs, he'll buy 60 chairs. And for each chair, if profit is rupees 75, then for 60 chairs he'll get a profit of rupees 4500. He kept on thinking whether he should purchase 20 tables or 60 chairs. Then he went to one of his friends who was a mathematics student and he suggested him to go for 10 tables and 50 chairs. 10 tables will cost him rupees 25,000 and 50 chairs will also cost him rupees 25,000. So the total amount he'll spend is rupees 50,000 and he has 50,000 available with him, and the total number of pieces he will purchase will be 10 plus 50, which is 60. Again, there is no problem as far as storage is concerned. And the profit on 10 tables will be rupees 2500 and 50 chairs will be 3750. So the total profit is rupees 6,250. It means instead of purchasing 20 tables or 60 chairs, it will be better for him to go for 10 tables and 50 chairs. Now, question is, how will we get such kind of solution? How will we come to know whether he has to purchase 10 tables, 50 chairs, or some other combination so that the profit is maximized? And we do not know whether this is a maximum profit or there exists some other values where he will get more profit. Now, let's try to solve the same problem mathematically. In case if we convert any real life problem into a mathematical problem, we introduce certain variables. Let the number of tables be x and number of chairs be y. And we know that the cost of each table is rupees 2,500 and each chair is rupees 500. And we know that he has certain limitations. The first limitation is that he cannot store more than 60 pieces. Means value of x plus y cannot exceed 60, hence x plus y will be less than equal to 60. The second limitation is the amount available with him. He can't spend more than 50,000 rupees. Hence, 2500 times x plus 500 times y can't exceed 50,000. So the second limitation, the second inequality which we'll obtain from the limitation is 2500x plus 500y is less than equal to 50,000. Other than this, we know that the value of x and y can't be negative. So x will be greater than equal to 0 and y as well. Students, these limitations in mathematical language, instead of using a word limitation, we use a word constraints. So in this chapter, we'll be using the word constraints. And what are constraints actually? Constraints are the inequalities which are obtained from the given question, which are nothing but the limitation which a person has. Now, next is objective. In this particular question, the main objective of LX is to maximize the profit. Now, what is a profit in this case? We know that profit for each table is rupees 250 and each chair is rupees 75. So total profit will be 250 times x plus 75 times y. We need to maximize this. We need to maximize 250x plus 75y, which will be the profit which LX will get. And generally we use a symbol Z for this. And this becomes a function and we call it an objective function in mathematical language. So students, any kind of linear programming problem, we also call it LPP, linear programming problem. We convert LPP into a mathematical problem by introducing certain variables, and we obtain the inequalities known as constraints and our objective function that will be either maximize or minimize z equals to again a linear function. Now next comes part 1 is over. We have converted a real life problem into a mathematical problem. Part 2 is how to solve this mathematical problem graphically. Step number 1 is the constraints which we have. Let's plot the graph for these constraints, and yes, wherever possible we can reduce any constraint into a simpler form. For example, 2500 times x plus 500 times y less than equal to 50,000. We can divide the whole equation by 500 and we can simplify that inequality. We will get 5 times x plus y less than equal to 100. Let's plot the graph for these four inequalities: x plus y less than equal to 65, x plus y less than equal to 100, x greater than equal to 0, y greater than equal to 0. Last two inequalities represent that the region will be only in first quadrant. X and y are positive only in first quadrant. Now let's plot the graph for the rest of the two inequalities. Last two we'll consider that the shaded region, the feasible region, will be only in the first quadrant. and here is a graph which we will obtain after plotting one by one after plotting these inequalities on a graph paper. This yellow shaded region is a common region which we will obtain, and this region is known as feasible region. Feasible region means in this region my all the constraints, my all the limitations are satisfied, means my solution will lie somewhere in this region. In this specific question, we have obtained a bounded region. Bounded means a region which has boundaries, a closed region. So students, there can be two different kind of possibilities. The first possibility is the feasible region is bounded, and the second possibility is the feasible region is unbounded. In case if feasible region is bounded, then the maximum and minimum value of objective function, which is z, will definitely exist, will always exist. And the corner point theorem says that the maximum or minimum value of z exists at the corner points, at one of the corner points of this bounded region. As far as unbounded region is concerned, we will take up the case in next question. Now let's see the bounded region. The bounded region has four corner points. So according to corner point theorem, our answer will be one of these four corner points. Let's again go to the graph, and here it is. The four corner points are 0, 0, 20, 0, 10, 50 and 0, 60. So next step is again done. We have already plotted a graph in which we obtained a feasible region as a bounded region. We obtained the corner points also. And I know that one of the four corner points is the maximum value of our objective function, that is the profit function. Next step is, what we are going to do is, at all these four corner points, we will find the value of our objective function, and this table represents the value of objective function at all four corner points. At 0, 0, the objective function is 0. At 20, 10, if we substitute 20, x equals to 20 and y equals to 0, we will get 5000. So if Alex purchases 20 tables and no chair, he'll gain 5000. And in case if x is 0, y is 60, means he goes for 60 chairs, no table, profit will be 4500. And in case if he goes for 10 tables and 50 chairs, the profit will be 6250, which is the maximum profit. So comparing these values of z, we will get the answer, the maximum or the minimum value, whatever is required in the question. In this case, the maximum value of z is 6250 for x equal to 10, means number of tables equals to 10 and number of chairs equals to 50. And now the Alex was very happy to understand the basic concepts of linear programming. Now he won't require the help of any of his friends to solve such small problem in his business. Now let's see, what if our feasible region is unbounded. In case the feasible region is unbounded, then for the given problem, maximum or minimum value of objective function may exist and it may not exist. It depends. But one thing is sure, in case the maximum or minimum value of z exists, it will exist at the corner points only. So if in a given question our feasible region is unbounded, we will do the question exactly in the similar way. We will find the value of objective function at all the corner points. The only extra step which we need to do is, in the end, we need to check whether the solution exists or not. If it exists, we are sure that it will exist at one of the corner points. Now let's take up an example where the feasible region is unbounded. Here is the question. There are two types of fertilizers, F1 and F2. F1 consists of 10% nitrogen, 6% phosphoric acid. F2 consists of 5% nitrogen, 10% phosphoric acid. After testing the soil conditions, a farmer finds that she needs at least 14 kg of nitrogen, means the fields require 14 kg of nitrogen and 14 kg of phosphoric acid too for the crops. If the cost of first fertilizer is rupees 6 per kg and second fertilizer F2 is rupees 5 per kg, determine how much of each type fertilizer should be used so that nutrient requirements are met at a minimum cost. It means the cost of fertilizer need to be minimized. Obviously, the farmer will not like to spend too much of amount on the fertilizer, will spend minimum amount. This question, I generally get confused with, long statements. I always prefer, wherever possible, I always prefer to draw, to give a tabular representation to such lengthy questions. Now, this table represent the whatever information is there in the question. I have written in the form of a table the nitrogen requirement. If you see in the bracket, it represents 14 kg. It is in kg. Phosphoric acid is also 14 kg is a requirement, and price per kg of both the fertilizers is given. First fertilizer contains 10% nitrogen, 6% phosphoric acid, and the cost is rupees 6 per kg. Second fertilizer contains 5% nitrogen, 10% phosphoric acid, and cost is rupees 5 per kg. Now, let us consider that the quantity of first fertilizer required is X, and for the second fertilizer required be Y. So first of all, we will introduce the variables in order to convert a given real life problem into a mathematical problem. Now let's try to form the constraints, the limitations which the farmer has. The first one is the minimum amount of nitrogen required is 14 kg. If he is using X kg of first fertilizer, then that fertilizer will contain 10% of X nitrogen, and F2 will contain 5% of Y nitrogen, which has to be greater than or equal to 14. It means the inequality will become 0.10x means 10% of x, and 0.05y means 5% of y. It has to be greater than or equal to 14. 14 kg is a minimum requirement. The second inequality will be 0.06x plus 0.10y, and again it has to be phosphoric acid. Its requirement is greater than or equal to 14. Then obviously x and y cannot be negative, so our last two constraints in almost all the questions will take x and y as positive quantities. The objective in this specific question is we need to minimize the cost of fertilizers, means our fertilizer cost of fertilizer, which is 6x plus 5y, needs to be minimized. So I will use the symbol z to minimize the function, and we are going to minimize z, which is equal to 6x plus 5y. So this is the objective of our question, and this is our objective function. So step 1 is complete, converting a real life problem into a mathematical problem. Step 2, plot graph for all the inequalities, and here are the graphs of all the inequalities. And the three corner points are 0, 280, 100, 80, and 233.33, 0. And if you observe, this region is unbounded. Unbounded means it doesn't have the boundaries. It will extend up to infinity. Now next step is again similar. What we are going to do is we will find the value of z at all three corner points, and these are the values of z at all three corner points. Now our aim was to minimize z, and from this table we can see that the minimum value of z exists at 100, 80, means 100 kg of fertilizer 1 F1 and 80 kg of F2 is required. But since the region is unbounded, I am not sure whether the solution exists or not. But one thing which I am sure about is, if solution exists, then the solution is 100, 80. The only thing which I need to check is whether the solution exists or not. The method to check whether the solution exists or not is very simple. I will do it with contradiction. I will suppose that the value of z can further be reduced, means z can be less than 1000. So I will consider that the value of 6x plus 5y can be less than 1000. Now let us see in which region is 6x plus 5y is less than 1000. Let's plot the graph of the last inequality which we have obtained, that is 6x plus 5y is less than 1000. And since it is a strict inequality, equal to sign is not there, we will obtain a dotted line. So this is a dotted line which I will obtain for this graph. Since 0 comma 0 satisfies this inequality, so the shaded region will be towards the origin, and here is a shaded region. This green shaded region represent that the value of Z, the total cost of fertilizer, can be less than 1000 in this region only, and the yellow shaded region is my feasible region. If you observe both the shaded regions carefully, there is not even a single point which is common in green shaded region. Green shaded region means cost less than 1000, and yellow shaded region means my feasible region. It means inside the feasible region, the cost cannot be less than 1000. The cost can be less than 1000 outside the feasible region. Hence, our solution is 100, 80, because inside the feasible region the minimum cost is 100, 80, means F1 100 kg and F2 80 kg. In case if we obtain some common points or common region between yellow and green portion, in such cases the solution will not exist, means there will not be any minimum or maximum value of objective function in that specific question. So students, this was all about the linear programming problems for bounded regions and unbounded region. And in next part of this video, that is linear programming problem, we will discuss transportation problem. So till then, thank you and have a nice day.